Hello students. Today we will discuss next topic and name of the topic is conductance. Okay. So last time we discussed about the numericals on Nernst equation. Okay. Nernst equation, very important. Okay. One more derivation is left. So before starting this, I am telling about that relation with equilibrium constant. Last time I told you E cell is equal to E naught cell minus 0.0591 upon n and log concentration of product upon concentration of reactant. Student, suppose I have two cell number 1, cell number 2. These are half cell and these cells are connected with each other through salt bridge. Okay. So at student, after some time, potential difference of these two cell will be same. Mean potential of this cell that is on right hand side will decrease and potential of left hand side will increase. And there will be a condition when both cell will have the same potential. Okay. So what will be the value of E cell? E cell is the potential difference of reduction potential of cathode minus reduction potential of anode. If both will have same reduction potential, so value of cell, that is E cell, will be 0. Okay. So this stage is known as stage of equilibrium. So at the stage of equilibrium, no current will flow in the cell. E cell will be 0. Okay. You will keep in mind that at the stage of equilibrium, no current will be flow in the cell because potential difference will be 0. Mean potential of cathode and potential of anode will be same. Okay. And when potential of cathode and anode is same, then this part, that is concentration of product and concentration of reactant, is known as equilibrium constant, known as log Kc. In class 11th we have discussed about this. Okay, product upon reactant. So on rearranging, what will be the value of Kc? Or you can calculate E naught cell. E naught cell is equal to 0.0591 upon n log Kc. Okay. So student, I am calculating the value of, you will keep in mind this equation because I am removing the content. Okay. E naught is equal to 0.0591 upon n log Kc. Okay. So what was the equation, student? E naught cell is equal to 0.0591 upon n log Kc. So n into E naught cell is divided by 0.0591 is the value of log Kc. Okay. So bring the log here, and what will be the value of Kc? So 1 upon log will be in the denominator, na? 1 upon log is known as antilog. Antilog n into E naught cell upon 0.0591. So using this equation, student, you can calculate equilibrium constant Kc for any reaction. Important है, बहुत बार एग्जाम में इससे रिलेटेड न्यूमेरिकल आए हैं. ओके. सो Kc इज इक्वल टू एंटी लॉग n E naught cell upon 0.0591. And how will you calculate E naught cell? E naught cathode minus E naught anode, that is higher value minus lower value, reduction potential of cathode minus reduction potential of anode. Okay, वो तो आप फाइंड कर ही लेंगे. So today we will discuss this. What's the formula here? Log Kc is equal to, looking this one ना, so log यहाँ ले आओगे आप, ठीक है, so it will be the formula. So student, next we will discuss cell conductance of electrolytic solution. So conductance, already you have studied conductance. Conduction or conductance mean the flow of ions, okay. So students, we know that one more term, resistance, okay. So we will discuss one by one. So what is resistance, students? It is the barrier in the flow of current. We know that resistance already in class 8th 9th we have studied it, directly proportional to the length of the wire and cross section of the wire, okay. Higher will be the length, this is sign of proportionality. Higher will be the length, higher will be the resistance. But if higher will be the cross section area, then resistance will be low. Similarly student, here we are not studying the resistance of the wire, we are studying the resistance or conductance of a solution, okay, in which ions are there, and these ions that is plus or minus, or all plus all minus, they are moving in the solution, okay. So what is the movement of these ion will represent the conductance and resistance. So students, in this, what do? Generally we use a cell like this, and this cell, okay, is used to determine the conductance of this solution. Mean, suppose this is the solution of sodium and chloride, that is sodium chloride, okay, and sodium and chlorine are moving in the solution. In sodium chloride, sodium ions and chloride ion are responsible for the conductance. So what will happen student? How we will measure its conductance? We will use a instrument is known as conductometry, and in the conductometry a electrode rod is dipped here, okay, and this electrode will automatically calculate its speed, that is speed of ions, and will give the answer of conductance, okay. What is the conductance, okay. So student, we will check the length of this electrode. So this is what? Length is the length of electrode, and A is the cross section area of this electrode, okay. So we are using this electrode to calculate the conductance of the solution, okay. So student, again what I told you, resistance is directly proportional to the length of electrode and cross section area of electrode, okay. In place of proportionality, we will put a constant and is known as proportionality constant, and here rho is the known as resistivity, okay. So what will be the unit of resistivity? R, okay. So R will be rho is equal to R into A upon L, or unit of R is ohm, and A is the area will be centimeter square, upon length is also centimeter, so unit is ohm centimeter, okay. So this is the unit of resistivity, okay. And what is resistivity student? Resistivity is the resistance of electrode or wire having the length of 1 centimeter and having the cross section area of 1 centimeter square, okay. So take the L and A as unity, so rho will be equal to R. It is clear? Similarly, one more term, that is conductance. Here I will use the conductance as G, okay. So G, that is conductance, is directly proportional to the cross section area and inversely proportional to the length, that is it is inversely proportional to the resistance. We know that conductance is always inversely proportional to the resistance. Or what will I do? I will put a constant, okay. When I will remove this sign, then I will put a constant एंड दिस कांस्टेंट इज नोन एज कापा के, ये वाली लेग जो है इसकी थोड़ी बड़ी बनानी है, कापा, ओके। एंड कापा मीन कंडक्टिविटी, कापा मीन कंडक्टिविटी। सो व्हाट इज कापा? आई एम राइटिंग हियर, कापा इज कंडक्टिविटी, okay, and this conductivity is what? It is the reciprocal of resistivity, it is the reciprocal of resistivity। क्यों भाई? जब कंडक्टेंस इन्वर्सली प्रोपोर्शनल होती है रेसिस्टेंस की, तो कंडक्टिविटी क्यों नहीं इन्वर्सली प्रोपोर्शनल होगी रेसिस्टिविटी की? तो अच्छा, इसकी यूनिट बता दो फिर क्या होगी, कापा की यूनिट क्या होगी? जो कंडक्टिविटी, जो आपकी रेसिस्टिविटी की यूनिट थी, उसको हम क्या कर देंगे? इन्वर्स कर देंगे, यानी कि ओम इन्वर्स और सेंटीमीटर इन्वर्स will be the unit of what? Will be the unit of conductivity kappa, okay? It is clear or not? And what will be the value, definition of conductivity kappa? Conductivity kappa is the conductance of a solution having the cross section area 1 centimeter square per unit of length, okay? Or you can say it is the inverse of resistivity. So this is very very important student. This ratio, this one is also known as cell constant। क्या कहलाएगा ये? cell constant। ये बहुत इंपॉर्टेंट है स्टूडेंट, सेल कांस्टेंट। क्यों कहलाएगा ये सेल कांस्टेंट? देखो, ये सेल की लेंथ और सेल, मैंने शुरू में ही बताया था, सेल की लेंथ होगी जिससे वो इलेक्ट्रोड जो हम किसके अंदर डिप करेंगे, इन अ सॉल्यूशन विच विल डिटरमाइन द स्पीड ऑफ Na पॉजिटिव एंड Cl नेगेटिव आयन। सो always it will be constant, length of the cell will be constant and cross section area will also be constant. So the ratio of L upon A is known as cell constant and its value will always be constant, okay? ये बात आपने ध्यान रखनी है। अच्छा, तो ये क्या फॉर्मूला बन गया? देखो, सेल कांस्टेंट resistance is equal to rho into cell constant. I'm roughing this one, note it carefully, take the screenshot, okay? So I will start from this formula, okay? Look here, what I said, resistance is equal to resistivity and L upon A, and L upon A is known as cell constant, so and one what is this? This is 1 upon kappa, okay? अभी मैंने आपको बताया resistivity is the reciprocal of conductivity. So cell constant is equal to resistance into conductivity. Very very important formula student, very very important. How will you calculate cell constant? You have two method, either L upon A, okay, or R into, R is the what? Resistance into kappa. Kappa is what? Conductivity. अच्छा, एक और है, ये तो हो गई लेंथ। एंड व्हाट इज A? पाई आर स्क्वायर। एंड पाई आर स्क्वायर किसका एरिया होता है? यू विल टेल मी इन द कमेंट बॉक्स, ओके? पाई आर स्क्वायर, ओके? सो सेल कांस्टेंट इज लेंथ अपॉन A, that is pi r square, length upon pi r square, or you can say cell constant is equal to resistance into kappa, okay? Resistance into conductivity, clear है? Okay, next come to the topic. Already I have explained all these topic, 1 upon r, ठीक है ना? Look here, kappa is equal to 1 upon rho and its unit is ohm inverse, centimeter inverse, okay? Or here ohm inverse is known as Simon, is known as SIMEN, Simon. So you can say Simon centimeter inverse, this is SI unit, okay? Look here, Simon centimeter inverse. Next is molar conductance and molar conductivity. Next is molar conductance. So student, molar conductance is generally what? Suppose you have made a 1 liter solution, or you can say VML of solution, and you have dissolved some 1 mole of NaCl, 1 mole of NaCl. So here Na positive and Cl negative will move in this solution. whose volume is VmL, or you can say V centimeter cube. Okay, कोई जरूर नहीं है 1 लीटर लेना है, आप 250 ml ले लो. Okay, whatever the volume. So conductance of 1 mole of electrolyte present in V centimeter cube of solution. Student, listen carefully. Conductance of 1 mole of electrolyte mean which will give ion, present in V centimeter cube or V ml of the solution is known as what? Molar conductivity, because we are taking 1 mole. Second thing, suppose I am taking NaCl and its value is not 1 molar, its value is 1 gram equivalent. Class 11th, how will you calculate gram equivalent? Moles कैसे निकालते थे आप? Moles given amount upon molecular weight. And how will you calculate gram equivalent? Given amount upon equivalent weight. Solution वाले चैप्टर में ही बताया था. Okay, so if 1 gram equivalent is present in V centimeter cube of solution, then it is known as equivalent conductivity. So what is the difference between molar conductance and equivalent conductance? In molar conductance we take the conductance of 1 mole, and in equivalent conductance we take the conductance of 1 gram equivalent. And what will be the formula, student? Conductance we will use lambda m for molar conductance. It is equal to the kappa into 1000 upon molarity. Why we are taking molarity? Because molarity will represent mole. And equivalent conductance, it is equal to kappa into 1000 upon normality. Okay, student. So what will be the unit of molar conductance? What was the unit of kappa? It was the ohm inverse centimeter inverse. यही थी कि नहीं थी? Again I am writing, student. What? Ohm inverse or and centimeter inverse upon what is mole? Molarity. Mole per liter. Per liter होगा तो वो ऊपर आ जाएगा. And value of liter is, unit of liter is cube, centimeter cube. I am writing again. So lambda m was kappa into, derivation नहीं है इस फॉर्मूले का, आप डायरेक्ट याद रखेंगे, 1000 into molarity, and kappa is ohm inverse centimeter inverse upon molarity is mole per liter. लीटर में यहाँ लिख लेता हूँ. And unit of liter is ohm inverse centimeter cube is the unit of volume upon mole. Okay, so ohm inverse centimeter square is left per mole. So this is the unit, student. मोलर कंडक्टेंस की यूनिट देख लो, ओम इनवर्स सेंटीमीटर स्क्वायर पर मोल, और ओम इनवर्स इज नोन एज साइमन. सो साइमन सेंटीमीटर स्क्वायर मोल इनवर्स, साइमन सेंटीमीटर स्क्वायर मोल इनवर्स. सो आई एम राइटिंग द यूनिट ऑफ ईच. व्हाट? कापा, देन लैम्डा एम, देन लैम्डा ई क्यू. इट्स यूनिट इज कापा. हाउ विल यू कैलकुलेट कापा? वो मैंने आपको बताया भी था, सेल कांस्टेंट upon resistance. Okay, you will calculate this one. And lambda m, kappa into 1000 upon molarity, and lambda eq, kappa into 1000 upon normality. Its unit is ohm inverse centimeter inverse or Simon centimeter inverse. Its unit is ohm inverse centimeter square mole inverse or Simon centimeter square mole inverse. This is mole inverse, student. Here ohm inverse centimeter inverse. Here we will not take mole, we will take gram equivalent. Or second unit will be Simon centimeter square gram mole inverse, gram equivalent minus 1. So it will be the यूनिट। ओके स्टूडेंट, आई होप आपको ये सारे टॉपिक जो होंगे वो समझ में आ गए होंगे। ये फॉर्मूले मत भूलना, ओके, बिकॉज नेक्स्ट टाइम वी विल डिस्कस द एक्सरसाइज ऑन these three formulae. What? Kappa is the conductivity, lambda m is the molar conductance, lambda eq is the equivalent conductance. Okay, molar conductance is the conductance of 1 mole of electrolyte present in v centimeter cube of solution. Equivalent conductance is the conductance of 1 gram equivalent of a solute or electrolyte present in v centimeter cube of the solution. Okay, so here is the equivalent conductance and its formula. Okay, here is the unit. Okay, ohm inverse, centimeter square, gram equivalent, or Simon centimeter square mole conductance. So next time we will discuss next topic, that is what? Student, it is the formula kappa. Conductivity is the conductance into cell constant. Okay, so next time we will discuss the formula, that is variation of conductance with dilution, and this is very very important. Okay, so tomorrow we will discuss this question. Goodbye.